Hey everyone, welcome back to NEX GEN. On this channel, we build real-world web and mobile applications, not demo projects, not fake examples, real apps that you can actually use in your portfolio. Let's start. In this video, I'll explain how the entire app works, the architecture, Firebase integration, notification logic, and finally how to test and deploy it. Let me show you what we're building today. Opening the app with a custom logo. I found this somewhere on the internet. You can get your own if you want. I will show you the medicine list, how to add a pill, show the time picker, wait, and show a notification pop. This is a pill reminder mobile app built using React Native, Firebase, and push notifications. The app reminds users to take their medicine even when the app is closed. Medication reminders are a real problem, especially for elderly people and patients with long-term prescriptions. Instead of just explaining concepts, I built a complete working application that solves this problem. This project is perfect if you are a student, building a portfolio, preparing a final year project, or learning how real production apps are structured. I'm not going to live code in this video. The code is already written. My focus is to help you understand how everything works together. App flow explanation. Let's understand the app flow first. The user adds a medicine name, selects dosage and reminder time, chooses frequency, daily, or custom. Data is stored in Firebase. At the scheduled time, a notification is triggered. The key point here is reminders work even when the app is closed. This is not just UI. This is actual background notification logic. Project architecture. I am using VS Code and Android Studio with emulator. You can use Expo Go app in a physical device too to test this as live app. When building a health utility app like this, the architecture needs to be two things: scalable and reliable. We're using React Native for a seamless cross-platform experience, Firebase as our real-time backbone, and a dedicated background notification engine. In the next 4 minutes, I'm going to break down exactly how the data flows from a user's tap to a background alert that works even when the app is completely closed. Let's dive into the project structure. Let's start with the front end. The app follows a modular component-based architecture. In our Screens folder, we have 3 primary views: the dashboard, which fetches and displays the medicine list; the Add Pill screen, where the logic for data entry lives; and the settings for notification preferences. We use React Navigation to handle the transitions. For the state management, we've kept it lean, using React hooks like useState and useEffect to manage local input before it's sent to the cloud. One key detail here is the custom time picker component. It doesn't just capture time, it formats it into a Unix timestamp that our notification logic can understand. This is the first step in ensuring the reminder hits exactly when it's supposed to. Backend and Firebase integration. Component architecture. Now, let's talk about the brain of the app, Firebase. We're using Firebase Firestore as our primary database. Why? Because it's real-time. When a user adds a pill, that data, including the name, dosage, and frequency, is stored as a document in a reminders collection. Collection name might be different in your case. Each document is tied to a unique user ID. This architecture allows us to sync data across multiple devices. If you change your pill schedule on an iPad, it reflects instantly on your iPhone. But storage is only half the battle. The architecture also includes Firebase authentication to keep user health data private and secure. All communication between the app and the database is handled through a dedicated service layer in our code, keeping our UI components clean and focused only on what the user sees. The notification logic, background tasks, was completely code-based logic, so it feels a bit boring to watch, but good to know the concept and logic behind it. The most critical part of this project is the notification logic. A pill reminder is useless if it only works while the app is open. To solve this, Our architecture implements push notification tokens and a background task runner. When you save a reminder, the app triggers a local scheduling service. We use the Expo notifications, or React Native push notification library, to hook into the OS-level alarm manager. Here's the flow. The app calculates the delay until the next dose. It schedules a trigger with the mobile OS. Even if you kill the app or restart your phone, the OS keeps that trigger in its queue. This offline-first approach for reminders ensures that the notification logic lives independently of the app's lifecycle. It's the difference between a simple UI project and a real-world utility app.